Plug power is scaling hydrogen, but ESG could kill the economics. Something unusual is happening in the hydrogen market right now. On the surface, everything looks like acceleration. Gigawatt announcements, infrastructure buildouts, new partnerships, and capital flowing into production, storage, and distribution. And at the center of that expansion sits Plug Power, positioning itself as one of the key builders of the hydrogen economy. But if you step back and look at what's actually happening beneath the surface, a different picture starts to emerge. Because the real constraint is not showing up in the technology, it's showing up in the capital. And the mechanism behind that constraint is ESG. Not ESG as a buzzword, not ESG as reporting, but ESG as a system that determines whether projects get funded or quietly disappear before a final investment decision. This is where the investigation begins. Plug Power's strategy is not just about scaling hydrogen production. It's about building an integrated system: generation, liquefaction, logistics, storage, and end-use integration. Increasingly, that system is being positioned for high-demand, high-reliability applications like data centers, industrial clusters, and logistics networks. On paper, it's exactly what the energy transition needs. Hydrogen can store renewable energy, provide continuous power, and decarbonize sectors where electrification struggles. So why is the system under pressure? Because the moment hydrogen moves from technology to infrastructure, it enters the financial system, and the financial system runs on ESG, not as a guideline, but as a filter. This is the part most people misunderstand. ESG is not a sustainability label, it is a risk pricing mechanism that determines whether a project qualifies for capital, and at what cost. And once you see it that way, everything changes. Because ESG doesn't sit on top of the system, it sits in front of it, like a gate. Or more accurately, a series of gates. First comes environmental screening, carbon intensity, energy source integrity, water usage, life cycle emissions. If a hydrogen project cannot demonstrate low and verifiable emissions, if it relies on grid power during renewable gaps, or if it operates in water-stressed regions without mitigation, it begins to fail this layer. And when it fails, something very specific happens. It loses access to green capital, green bonds disappear, preferential debt pricing disappears, subsidy eligibility may weaken, and suddenly, the cost of capital increases. Then comes social risk. Permitting timelines, community acceptance, workforce conditions, supply chain transparency. This is where projects don't fail loudly, they stall. Delays extend timelines, costs accumulate, financing windows close, and the project becomes economically unstable before it even begins. And finally, governance. Risk management, transparency, accountability, board oversight. This is where investors ask a simple question. Can this project actually be controlled? Or is it too complex, too opaque, too risky to finance? At each of these layers, capital narrows, not gradually but decisively. Because ESG is not about doing good, it is about surviving scrutiny. And if a project fails any one of these gates, it doesn't just become less attractive, it becomes more expensive. And when it becomes more expensive, the entire economic model shifts. This is where Plug Power's scaling strategy meets reality. Because scaling hydrogen means scaling exposure to ESG filters. Take a simple example, a hydrogen plant powered primarily by renewables. On paper, it's green. But in reality, renewable supply fluctuates. So during low wind or solar periods, the plant draws electricity from the grid. Now carbon intensity increases, not permanently, but intermittently. And that intermittency matters. Because under strict frameworks like EU taxonomy or RFMBO rules, classification depends on consistent compliance, not averages. So even limited grid usage can push a project out of green classification. That single shift triggers a cascade. Green financing is lost. Debt becomes more expensive. Off-takers lose the ability to claim emissions reductions. And suddenly, a project that looked financially strong begins to weaken. We've already seen this effect. A hydrogen project can start with an internal rate of return around 14%, but fail ESG classification due to carbon intensity during partial grid usage. That removes access to lower-cost green financing. Debt pricing increases, and that same project drops closer to 11 to 12% IRR. That is not a marginal change. That is the difference between investor approval and project rejection. And this is where the real system stress appears. Because hydrogen economics are already tight. They depend on high utilization, low electricity cost, stable offtake, favorable financing. ESG directly affects all four. Now layer in another constraint: water. Electrolysis requires purified water. Not just availability, but treatment, infrastructure, and discharge management. Many of the best renewable regions are also water constrained. So now the project faces another ESG filter. Water stress. Permitting risk increases. Environmental scrutiny increases. Operational costs increase. Again, not a failure of hydrogen, a failure of system alignment. Now zoom out further. Plug power is increasingly targeting continuous energy demand systems, including data centers. This is strategically important because data centers need 24/7 reliability. Hydrogen can provide that. But this introduces a critical tension. To maintain continuous hydrogen supply, systems often need to operate beyond pure renewable windows, which means either you accept intermittency and lose reliability, or you use grid power and risk ESG noncompliance. This creates a structural conflict, reliability versus ESG, and that conflict directly impacts utilization. Lower utilization increases cost per kilogram, higher cost weakens competitiveness, and weaker competitiveness makes financing harder. This is the loop, and ESG sits at the center of it. This is why the hydrogen industry is entering a new phase, not a technology phase, an execution phase, where success is no longer defined by building capacity, but by surviving constraints, capital constraints, regulatory constraints, system constraints. And ESG is the framework that connects all of them, because ESG is not evaluating hydrogen. It is evaluating whether hydrogen projects can survive in the real world. And this is where most of the market is still misaligned, because the conversation is still dominated by scale, megawatts, gigawatts, announcements. But the real question is different. Which of these projects can actually pass through ESG filters and reach final investment decision? Because that's where the bottleneck is forming, and that's where the winners will emerge. The companies that understand this will design projects differently. They will align energy supply with ESG requirements from day one. They will manage water, carbon, and utilization as a single system. They will secure cheaper capital, and they will scale. Everyone else will struggle, not because hydrogen failed, but because the system rejected them. And this is exactly where most projects fail, not in the technology, but in aligning with the systems that fund them. Because today, ESG is not a reporting exercise, it is a capital filter. If your project doesn't pass it, funding disappears. And that's why understanding how hydrogen, infrastructure, and ESG connect at the project finance level is no longer optional. It's foundational. If you want to go deeper into how these systems actually work, how ESG ties directly into hydrogen economics, capital access, and real project execution, you can explore the ESG Plus Energy Systems program inside H2 Hub by ReneEnergy. Because this is the layer where projects are decided. Not announced, not hyped, but funded or rejected.